Welcome back, guys. I'm really excited to share this project with you. This is going to be a bit of a longer video because I left in a lot of the technical stuff that I had to go through, some of the troubleshooting and difficulties that I ran into building this, but it is a Sci-Fi energy cell inspired battery bank, and this is I think the only project I've done so far where my biggest concern was looks. Now you might be thinking, wow, really? You were concerned about looks and it still looks like this? But I have decided that this is a Gen 1. I have learned a lot, and I know of quite a few things that I'm going to do differently for my next one. I am going to build another one, but for now, just sit back, make some popcorn, and watch me struggle to get this thing together. It was a really fun project. I learned a lot doing it. But yeah, anyway, sit back, like I said, make yourself some popcorn, grab a snack, pour yourself a drink. Big sip, gang. Stay hydrated and enjoy. So as I was designing the first iteration of this, I'll show you. I realized I didn't leave enough room for the battery charging module and the power delivery system, which is on this board. I don't know what I was thinking. I knew that I had to put it in there, but I guess I just forgot about it. I forgot that it was bigger, I guess. But anyway, this one is almost 10 centimeters in diameter, which I don't like. It's too big, so I'm going to try to rotate this. Ah, nice it is. Okay, cool. All right, I think we're cooking now. Okay. All right, so good news. I printed a small footprint of the battery housing, just to make sure that the dimensions that I was using to house the battery would work. And I checked it. It goes through all of them, so I can do the 7-hour print, and it should house the batteries just fine. Got the cap that will house the charging device, the charging circuit board. The charge circuit and the Arduino fit in the center there, and I'm going to go ahead and just leave that completely open like that. That way I can put the transistor in there that I need to use to control the LEDs. I also soldered up the LED strips, left them over here. Also soldered up the LED strips that I'm going to be attaching to the booster. So the booster is going to take the 3.7-ish volts off of these cells, turn it into 5 volts. That 5 volts is going to go to the LED. The ground from the LED is going to go through a transistor, and that transistor is going to be controlled via PWM by the Arduino. The Arduino is also going to get a line in from these batteries. It's just going to be a straight voltage into an analog pin, and that'll get mapped to the values for the brightness of the LEDs, like the maximum brightness when they pulse, and also the length of the pulse. So the higher the battery charge, it'll go woo, 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 or something like really bright, like woo, 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 woo. And then as it uses the battery, it's just going to start to go like woo, woo. So it shows that it's like, okay, it's starting to die and it needs to be recharged. So that'll be really cool. I just need to find out a way to, or figure out a way to isolate the Arduino while it's charging, because if the battery charger senses that there's too much current draw, then it'll keep charging the batteries. But if the Arduino is pulling current and the LEDs are pulling current, it's going to think, oh, I still haven't charged yet, and probably overcharge the cells. So I need to figure out a way to make sure that does not happen, because that could be very dangerous. But yeah, so now I think I'm going to go ahead and print the full size of the housing. Once I do that, I can stick the LEDs on there and start wiring those up. I need to figure out how I'm going to isolate it while it's charging before I do that, though. So I've got 7-ish, probably 8 hours while that prints to figure it out. Pretty sure I can do that. So, yeah, let's go ahead and get to that. We've got the variable PWM. I think we've got it. Hell yeah. Okay, so I did a little more research on the charge board that I have, and it does cut power to the 5-volt output whenever it's charging. So if I can use the 5-volt output that's already on the board, that means when it starts charging, it'll automatically cut power to anything on that. So being able to run the Arduino off of that, I think will solve the problem of charging while the Arduino is draining it. Okay, so we got all the batteries within about 1/100th of a volt, which should be plenty close to safely weld these together. So what I'm going to do, start rotating these. This makes me kind of nervous. I've never done this before. Turn on the power supply, and so whenever you charge lithium ion like this, again, I do not recommend it if you don't know what you're doing, but basically you keep an eye on the voltage. You supply 4.2 volts, and that's not a very big voltage difference, so that should just trickle charge basically. Looks about right. Okay, so now I need to connect the positive charging line with the positive side of the bank and the negative line with the negative side of the bank. Oh, that's just so cool. I love it. I love it already. Searching my life, but then I found it. Now I won't let you out of my sight. I wanna keep this feeling forever and ever. I'm there when you need me. So, there we go. One thing I do want to check on this is the voltage on the 5-volt rails. That's so weird. I'm only getting 2 volts. But I need 5 volts off of that. I don't know why I'm not getting 5 volts. Let me try charging something. I don't understand. Okay, so we've welded up the main part of the battery bank, and I am running into a little bit of trouble. I'm still not getting a full 5 volts off of these USBs unless I plug a USB into it. So something is telling the board, hey, USB's plugged in, go ahead and supply 5 volts. But the voltage that I was reading on there was just a residual voltage. As soon as I hooked up my voltmeter, you can see the voltage start dropping, and so that means it's just a residual voltage left over somewhere in the circuit. But I am trying to figure out what tells the charge circuit to power this USB, but no dice so far. But yeah, we'll figure it out. Let's keep going. This is your reminder, if you haven't had a drink of water in a while, go ahead and take a big sip. Gotta stay hydrated, but I did receive one comment on my Reddit post about getting the 5-volt rail to stay powered. It was recommended that I short the data pins, which is kind of what I was thinking, but I didn't do that because whenever you hook like a micro USB cable up without it plugged into anything, the data pins wouldn't be shorted. So I don't know if that makes sense, but hey, I'll give it a whirl. It shouldn't be dangerous to any of the power circuitry, so why not? Let's give it a shot. I did figure out how to get the power to turn on. Now I'm going to change the mechanics of how it works a little bit because this needs to register a voltage difference across the ground and voltage pins. The way I'm fixing that is I have a 10K resistor going to one side of this push button, and then the other side of this push button is going to ground. So when this push button is pressed, it connects the 10K resistor between power and ground, which gives it the voltage difference. While this is being pressed, it's also providing power to the Arduino. So when I set the battery bank down, oriented something like this, it will press the button and activate the lights. When the battery bank is picked back up or tilted on its side, that push button opens the circuit, stops supplying power to the Arduino, and it removes this resistor from the circuit. So there is no longer any connection, and this stops supplying power to the 5-volt rail after a few seconds. So now that we got that figured out, I'm pretty happy with the progress I've made, except for one little thing. The analog values are reading about 400 right now, which is about half, a little under half of 1023. Now the reference voltage is 5 volts, so that means this is reading about 2.5 volts or a little less. But this is charged up to 4.16 volts, which should read about 800 on the analog value, but it's not. So I have to figure that out. Okay, so I've got, I'm not even going to try to trace the wires, but I've got the power supply at 4.2 volts confirmed with the voltmeter. And then we've got the Arduino reading that from the, here I am tracing the wires, to the A0 analog input pin. And then that is reading up here at 927, which is pretty close to what we'd expect, a little higher than what I expected, honestly, but I guess it goes up to 1023, so that's only 100 less, but anywho, yeah, that's closer to the value that I would have expected. And then coming back over here, so we're going to remember 920 for 4.2, and then we're going to change this down to 2.6, and just a little more. That's as far down as that goes, so there we go, 2.6, which should be reading about 500, 570, okay, so 570, we got that right. So why isn't it reading? Take this off here. It should be reading. Take this one off of that. It's getting voltage from that. Let's see, now I'll hook it up to here. So it should be reading almost 900. Oh, strange. Okay, well, Okay, well, at least I figured out that the Arduino does read the voltage correctly until I hook it up to the battery. So I'm going to try to figure out what's going on there. And GoPro's in the way. Going to try to figure out what's going on there. And yeah, that's what I'm going to do now. So I'll be right back. All right, so I think we've got it pretty much figured out. Although I don't know why the analog right here going into A0 is powering the Arduino. It shouldn't be, because that should be isolated from the power. Okay, so figured out why the analog pin receiving the voltage from the battery was powering the Arduino. The analog input has to be between ground and 5 volts plus or minus half a volt. So if you power the Arduino with 5 volts, it has to be from negative half a volt to positive 5.5 volts. So that was basically the voltage from the batteries was backfeeding into the Arduino, and I might have cooked it. Basically, I have to figure out a way to keep the voltage off of the analog pin until that button on the bottom is pressed. And I came up with, I think, a pretty clever solution. Okay, so yeah, we see here's the Arduino. This is just a rough sketch I sketched up. We have the 5 volts coming off of the charge board, the USB rail, the 5 volt USB rail. This is the push button on the bottom. Now, a capacitor between the 5 volt rail and ground will provide that, that short voltage difference that we need, because I don't think the Arduino by itself provides enough. I'm not sure why. I would think it does, but it hasn't when I've tested it. So we get this short charge of the capacitor, which pulls voltage from the 5 volt rail, which should make the charger be like, oh, something's plugged in, turn on. Then it splits off, goes to the LEDs, and then we have a current limiting resistor going into the Arduino, V in. I'm not using raw because apparently that one has a voltage regulator that drops a couple volts. So I'm going into V in instead, since this 5 volts should be regulated fairly well since it goes into USB devices. Then we have the analog voltage that comes across here and goes through a transistor. Now this transistor will only turn on when it needs to take an analog reading. So I need to program an extra GPIO pin or a digital pin to basically go high. The Arduino takes the reading and then go low. So the analog pin is only receiving voltage while it takes the reading, and then it turns back off. So that way, whenever I power it, it's not getting that analog voltage before the 5 volt power for the Arduino. And then, just the same as it does before, it outputs the PWM signal to this other transistor that controls the LEDs. So, I think we've solved a couple problems here, and I will have to hook this up and test it out. So, I think we're making pretty good progress. Let's put the new board on. Okay, so what I'm working on right now is I'm trying to get that capacitor when it is shorted to ground to get it to turn on the board. But lower value capacitors are not doing the job. This is a 0.1 microfarad, but a 22 microfarad seems to do it, but the problem with that is it drains so slowly compared to the 0.1 microfarad. Okay, it is at 0.01 volts, so basically drained. Let's push this button. And it does turn on. Cool, cool. Let's see if it turns on with just the capacitor. I had a 10K resistor in series with it, so it charged up slower, basically gave a longer load. But you can see over here, it's draining fairly slowly. And now the 5-volt rail is off. And I think to turn the 5-volt rail back on to get that differential voltage, I think we have to wait until this drains quite a bit. So let me hit the button again. Yeah, it's not activating the charge circuit. So I don't like the idea of it taking this long to drain, but I'm not sure what else to do because I need a bigger capacitor to activate this. I know I could probably put the resistor in parallel. That would give it an additional path to drain. So now the voltage should be 0. Yep. Okay, now let's hit the button again, see if that does it. Oh, sweet. It turned it on and it drained very quickly. Let me put this right here so we can see. Okay, so we've got the 10K resistor, the 22 microfarad capacitor. The 22 microfarad capacitor should give the load that we need to activate this rail. Okay, so the rail's off. 10K is in parallel. Let's hit it again. Sweet. And then it drains through the 10K pretty quickly. The only thing I might trade that out with 100K, depending on how bright the LEDs get, because I don't want too much current to go through the 10K. And if there's too much load in parallel with it, most of my current's gonna go through the 10K. Well, sweet. Looks like it's working pretty well. So I'm just going to go ahead and use this 22 microfarad. I don't have to use the booster circuit anymore because I've got 5 volts coming off of here, so I have a little extra space inside that I can work with. So adding a few of these components, a couple transistors, shouldn't be a big deal because we've got this whole area right here to work with now. Instead of just instead of a booster going there, we can put whatever circuitry in there we need. So awesome. I'm going to test this with the LEDs and make sure it still gets enough current, but I think we're making progress. Okay, now that I have this wired up, I am going to download the Blinky program to read the analog signal from the batteries. So yeah, I'm going to go ahead and do that program real quick and see if it works. Alright, so good news, I can eliminate this resistor because with the load of the LEDs and the Arduino combined, it's enough to drain the capacitor once voltage is removed, enough to where if I hit it again right afterwards, it comes on. And then as soon as I release, boom, it drops about 2.5 volts and then keeps trickling down from there. And then let's hit it again. Sweet. And then you'll see, once I let go, it'll drain, and these lights will turn off, indicating that the 5-volt rail is no longer providing power. Let's give it a few seconds. Okay, so the rail is now unpowered. If I hit it again, boom, pulls enough current to activate it, and we are in business. So now I'm going to test it with a lower voltage with the power supply. Okay, I've got 2.5 volts going to the analog pin. So theoretically, this should be a much slower and dimmer pulse. But it looks like it's still going pretty strong. Yeah, that looks really high. Let me turn it down even more. I don't know, it looks like it's the same brightness, to be honest. Let's turn it back down. I'll just turn it down to 0 volts, see what happens. Yeah, I need to see what the Arduino is reading. Okay, so right now the Arduino is reading 18 out of 1023, so it's an extremely low value, which is what I would expect. So let me turn the voltage up. Going to turn it up to about 4 volts. Okay, let me see what it's reading now. Okay, it's still only reading 18, which is strange. It makes me think this ground is going, yeah, 4.1 volts. Still reading, yeah, it's still reading 18, which is not correct. Okay, so we're back to trying to figure out why this is not reading the correct analog value. Okay, well, I kind of feel a little stupid because in the programming I said serial print bat in, which is the pin number, not the bat level, which is the variable that stores the analog input. So I was just printing out the wrong variable. It was working correctly the whole time. Anywho, so we do get, here, look at that. It should read around 920. Okay, yep, that read correctly. Now I'm going to test it against the voltage or the power supply so I can manipulate the voltages. About 2.6 volts, so it should read around 500. Okay, let's check that. Okay, that's reading 814. So I need to reduce that a bit more. Well, that's strange. I'm getting voltage spikes. Okay, so I have these little circuits here. They're very simple, but they read from 0 to 25 volts and output an analog signal. Since I can't seem to be getting what I was originally planning on doing to work, I'm just going to go ahead and use this. I'll probably take this header off and just solder the leads from the battery onto that. So that kind of fixes the problem, I guess. It looks like I'm getting a reasonable voltage, but I'm going to read what the analog inputs are at 4.2 and 2.7, and then map those values to what I need. So we're just going to do that and remap the values, and that should work just fine. Okay, so the newly mapped values are in the Arduino. When I press this, it should give the correct glowy bits. Okay, it's very dim. I've got it at minimum voltage, so that's good. Let me turn the voltage up. Nice. That's what we needed. So now it's brighter. Let me turn it back, the voltage back down again. Very good. Oh, okay, awesome. It's finally working. Hey, I think we're cooking, baby. I think we can start assembling all this. I am pretty excited.
I've been searching my life, I just couldn't find it. The special someone to give me my heart. I've been searching my life, but then I found it. Now I won't let you out of my sight. I wanna keep this feeling forever and ever. I'm there when you need me, whenever, whenever. Keep this feeling forever and evermore. I wanna keep this feeling. I'm there when you need me. Keep this feeling forever
Alright, so we're just about done. All I need to do is solder on the LEDs and pour the epoxy, and I need to solder on the negative terminal for the battery. These are the two power cables for the LEDs. The ground is on a transistor controlled via PWM. This is 5 volts. And then I will solder on the button onto the Arduino and across power. So just about done. We're getting pretty close to finishing up, so pretty excited. Man, I had a lot of trouble earlier today figuring out that analog thing. Yeah, I can't believe I was just reading the pin number instead of the actual analog input. Love it when a plan comes together, and this one's coming together pretty well, so pretty pumped. One thing that is going to delay me by a day or two is I was trying to solder the LED strips together in parallel, but it was proving very difficult to maneuver them into the slots with the wires soldered on there and avoid the copper pads coming up. So I ordered just a couple of these doodads right here. They just clip on, so there's not a solder connection, it's just a pinch onto the contacts, and the wires are already stuck on there, so it'll be more convenient. It'll be more reliable since there's not going to be that stress on the pad. So as soon as these come in, I can just solder them together really easy, and yeah, go from there. I'll be back whenever I have more progress made. Alright, so I went ahead and just finished up the design, and I didn't end up using epoxy between the batteries over the LEDs. I just used hot glue. There's a few things that didn't go the way I'd hoped when I was finishing the assembly, so I decided this was just going to be like version 1. I would like... Anyway, I decided this is just going to be version 1 because I would like to make another one. I learned a lot making this one, so I think if I make another one, it will come out much better and much more polished. But it does work. It is fully functional. I can set it down, and it does do the glowy bit. Isn't that cool? Pulses. Pretty neat. And then when you pick it up and release this button right here, it turns off. There's your battery indicator on the top. So right now it's indicating full charge. On the top we've got the indicator that's just the pulsing function, and that's going to, like I said in the beginning of the video, it's going to pulse quickly and more brightly the higher the battery level, and then it's going to pulse slower and more dim when the battery is lower. So anyway, yeah, I would like to do epoxy later, but I was going to have to pour one side, wait at least a couple days, pour another side, wait a couple days, pour another side, and I would have to remix it every time. Also, I couldn't get the white dye to mix properly. Even just for one drop, it made it way too opaque, and so I couldn't mix a small amount very easily, and so it just was going to be way too much of a hassle to use epoxy. I figured this was good enough for Gen 1. Now that I've decided I'm going to try another one and make it look even better. But yeah, that's Sci-Fi alien inspired energy cell. Has a capacity of almost 20,000 milliamp hours, so it'll charge your phone quite a few times. But yeah, see, check that out. Isn't that awesome? That's pretty cool. And then that way you don't use any battery. Anyways, Thank you guys for watching. If you like that kind of project and you'd like to see more in the future, let me know. Anyway, I am fairly happy with how this turned out, being it's the first time I've attempted something like this. So, like I said, I would like to make another version, make it more polished, more planned out, really figure out what I'm going to do. But having already completed one, it really gives me a better idea of what I need to plan for. So this was more of like a first mock-up. A functional mock-up. But hope you guys enjoyed that. Be sure to be kind to someone today, and I will catch you next time. Peace.